Alrighty guys, so in today's lecture we're going to be going a little bit deeper into our study of organic compounds by talking about something called functional groups. Now very simply put, functional groups are specific groupings of atoms. So this basically means that they're like a combination, a specific combination of atoms inside a molecule that has its own characteristic properties regardless of what other atoms are present in the molecule. So let's just say, for example, I'm just going to say a functional group, I'll represent it with Fg. So if I have Fg and it's in an organic compound, right? We learned how to draw the skeletal structure, so let's say it looks something like this, for example. Now, if you notice, this part right here is an entire molecule. But no matter what is in the rest of the molecule, these functional groups are special parts of the molecule that kind of do their own thing. They have their own special property. You could think of it as their own special abilities, and you're going to find them in different types of molecules. So let's say we have this functional group in this molecule, and then let's say we have another molecule that looks a little bit different, right? So let's say I have a molecule that looks like that, and we have the same functional group. So you can see that these are different molecules, but both of these functional groups will more or less have the same properties, even though the rest of the molecule looks different. So you can kind of think of them as a special combination of atoms, and no matter what molecule they're found in, they're kind of going to do the same thing, regardless of what the rest of the molecule looks like. Now, there are a lot of different types of functional groups, and we won't be able to talk about every single one of them, and we're not going to be able to go too deep into them, but we will go over them a little bit simply, and we'll go through the more common ones. Now, the first functional group that we're going to learn about are something called amines. Okay, so amines. Number one is amines. Now, there are different types of amines, but before we talk about it, let's talk about what this R means. You're going to notice that there are these R's. Okay, so when you're learning about functional groups, you will see the letter R a lot. Now, the letter R is not a specific element, right? Here we have nitrogen and hydrogen, right? So normally the capital letters mean the element that is corresponding on the periodic table. But when you see the letter R, make sure you guys write this down somewhere so you don't forget. But the letter R basically just represents it's a carbon chain, or it's part of an organic compound. Okay? So what does that mean? So for example, the letter R can basically be any number of carbons combined together. So basically, let's go over what an amine is. So an amine is a nitrogen, right, connected to R. So that means an amine is basically, it can be a carbon chain and there's a nitrogen at the end of it, which either can be connected to two hydrogens, right? And then another type of amine would be a nitrogen in between carbon chains. So we can have a carbon chain, a nitrogen connected to a hydrogen, which connects to more carbons, or it could be a nitrogen in between three different carbon chains. So you could have a carbon chain like this, and then you can have a carbon chain like that, and a carbon chain like that. So as long as you have a nitrogen connected to a carbon chain, either one carbon chain, right? There's one carbon chain here. There's two carbon chains here. There's three carbon chains here. Regardless of how many are connected to nitrogen, if you have a nitrogen connected to a carbon chain, it is called an amine. Okay? So that's simply what an amine is. It does get a little bit more complicated, but if you see a nitrogen connected to R, and we said R is a carbon chain, just know that that functional group is called an amine. Now, we're going to look at a real-life molecule right here. So this molecule is the chemical structure for methamphetamine. It's the drug that's more commonly known as meth. Now, I do want to make a disclaimer. We're going to be talking a lot about illegal drugs and illicit substances, but I in no way condone the use or abuse of any of these. We're just looking at their chemical structure because it's a good and relevant way for us to learn about these functional groups, and we can see that these functional groups are a part of these molecules that exist in our society and that we know about. So again, I don't condone the use of meth. I'm only talking about it so we could look at the chemical structure, and because you guys all know Breaking Bad is about meth. that was made by a chem teacher, but I'm not trying to say that I partake in that. It's just we're just looking at meth first because it's a good reference to a popular TV show. Now, methamphetamine right here, you're going to notice that there's a nitrogen, right? And nitrogen is connected to two carbon chains, right? We know that the corners are all carbon, so there's a carbon here, there's a carbon here, there's a CH3 here technically, and this is a carbon chain right here. So because this nitrogen right here is connected to two R's, right? R and R. This would be R and R. This part right here is going to be an amine. So this right here, this functional group is going to be an amine. Okay, so methamphetamine has an amine group in it because it has a nitrogen connected to two carbon chains. All right. Now, that term chain might be a little bit complicated because if you look at the left, right, you'll see that there are a bunch of carbons connected with each other, right? There's a carbon here, carbon here, carbon here, carbon here, and you kind of, every single corner is a carbon. So this kind of seems like a chain, but if you look here, there's only one carbon. But even though there's one carbon, this is still considered R, okay? Because there is a carbon there. So just keep that in mind. I know the language can be a little confusing. All right, so that's the first functional group that we'll be talking about. Next, we're going to look at alcohols. Okay, the next functional group is called alcohols, and alcohols are generally R, right, carbon chain connected to an OH, connected to me, right, Mr. O. Okay, so again, R just means carbon chain, so that means that you can have OH connected to one carbon right here. You can have OH connected to two carbons. You can have OH connected to that's four carbons. Or you can have OH connected to an entire like super complicated structure. It doesn't matter because there's an OH connected to a carbon, an R, it's going to be an alcohol. So if we take a look at a couple examples. This is ethanol. This is the chemical in alcoholic drinks that gets people intoxicated. You're going to notice that OH is connected to a carbon, and which is connected to another carbon. So this part right here would be the R, and this would be the alcohol functional group. This would be the alcohol functional group. Okay. This is another example right here. Now you're going to notice there's a OH connected to a carbon chain. So this would be an alcohol group, but you're going to notice that, hey, there's a N in between a carbon chain. So this right here would be an amine. So this molecule right here has one alcohol group and it has one amine group. Okay, so molecules can have more than one functional group. So just make sure you guys keep that in mind. All right, the next example we're going to be looking at is an ether. Now, ether is basically a carbon in the middle of a carbon chain when you have an O. Okay, so if you have a carbon chain like this and you have an O which continues, that's going to be an ether. If you might just have one carbon, so you might have an O connected to a carbon, connected to a big chain right here, that's going to be also an ether. So again, ether is an O in between a carbon chain. And this apostrophe just means prime, which means that this is a different carbon chain. Okay. All right, so real world example might be MDMA. The street name for MDMA is ecstasy. Now, if you look at ecstasy, MDMA, you're going to notice that right here you have an O connected to a carbon here and a carbon here. But you're also going to notice that there's another O right here, which is connected to a carbon and another carbon. So in MDMA, there are going to be two ethers. Okay, and you're going to notice on the other side right here, there's an N connected to two different carbon chains. So there's also going to be an amine inside ecstasy as well. So MDMA is going to have two ethers and one amine. So again, this would be an example of a chemical that has more than one functional group. All right, the next example the next type of functional group we're going to look at is going to be called a carbon ring. Now, a carbon ring, as you guys might guess, is a ring, right? Not just a circle, though. It's a closed shape made of carbons. Okay, so we have a couple different examples here. So if you notice, we have this hexagon figure. Now, it's going to be a ring, right? A closed shape made of 6 carbons. So this would be a carbon ring. Here we have a triangle. We have 3 carbons that make a closed shape. So this would be a carbon ring. And then if you notice, there's an N right here. So this would be another example of an amine. We have another closed shape right here. This one has 2 double bonds though. But it doesn't matter if they're single bonds or double bonds. It's still all carbon, so it's going to be a carbon ring. And here you're going to notice that there's actually 2 rings, right? We have a ring right here on the left. I'll do that in pink. And then we'll have another ring here on the right, which I'll do in blue. And I know they share a side, right? This part in the middle, they share it. But this is still going to be considered a carbon ring. This is actually 2 carbon rings. Now, an example of something that's not a carbon ring is this right here, because if you notice, it's a closed shape, but there is an O in the middle of it, right? So this is actually not going to be a carbon ring because it's not a completely closed shape with only carbons. Instead, this part right here, it's an O connected to 2 carbons. So this is actually going to be an ether. This is not a carbon ring. So just make sure you're careful about that. If you want to call something a carbon ring, just make sure that all the sides, all the corners of that closed shape are carbons. All right, we're almost done. Now, sometimes when you're going through organic compounds, you're going to notice that with the smaller ones especially, that a lot of times you're not going to have these functional groups. You're not going to have an amine. You're not going to have alcohol. You're not going to have a carbon ring. And if there's nothing better, we have these consolation prize functional groups, you can call them. Okay, so basically, you have, if your organic compound only has single bonds. Okay, if it only has, I cannot spell. If it only has single bonds, okay, between carbons, we're going to call it an alkane. So this would be an example of an alkane because if you take a look at this structure right here, the only thing that it has is carbon, 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 and they're all single bonded. So if the only thing in your organic compound is single bonds between carbons, we call that an alkane. But here you're going to notice that you have single bonds between carbon, but there's an alcohol group. This would not be considered an alkane. This is considered an alcohol. And the reason why is because it has something, I guess, better than an alkane. So if there are only single bonds between carbons, we call it an alkane. But if there's something more interesting, like an OH, we'll call that an alcohol. Okay, so another functional group that is kind of like a consolation one that we use when there's nothing else is called alkenes. And we call something an alkene if there is a double bond. Okay, if there's a double bond between carbons. Okay, so this one right here would be an alkene because the only interesting to look at is going to be the double bond between the carbons. But here, the one on the right is not going to be an alkene because there is a double bond between carbons, but there's something more interesting. There's a nitrogen, so this would be an amine. Okay, this would not be an alkene because there's something more interesting than the double bond. So if the only thing that's interesting to look at in your structure is a double bond between carbons, we'll call that an alkene. All right, and then lastly, you guys can probably guess what the next one is. It's the one that we haven't talked about yet. It's a triple bond. If we have something where the only interesting thing to look at is a triple bond between carbons, we'll call that an alkyne. Okay? Alkyne. So here on the left we have an alkyne because there's a triple bond between carbons, but here we have a triple bond between carbons, but we have an O in between. So this would actually be considered an ether. This is not an alkyne because there's an ether. There's a O. So again, alkanes, alkenes, and alkynes, we only use them if there are no other functional groups inside the molecule. Alright, so those are the 7 functional groups that will be on your assignment today. It's basically what we just did in the examples. You're just going to get a molecule, and you're going to have to tell me how many of each functional group are inside each molecule. So hopefully this was helpful, and let me know if you guys have any questions, and we'll see you guys next time.